wonderful speakers at the end of the session to take any Q&A. So please do feel free to put any Q&A up as we go through. Okay, I'll just wait another few seconds and then I think we'll get started. Just as we're waiting, please be aware we've held over 12 webinars across this week. So if you are keen to go back and watch any of the webinars, they're all now available on demand on our website. You can simply go back, log back in, and you can watch any of the webinars on demand as well throughout the week. Okay, I think we are good to start. Thank you very much, everybody. So I would like to start by introducing our speakers this morning. We have Katy Milne, who is the Head of Industrial Strategy for FlyZero, part of Aerospace Technology Institute. And we have her colleague, Alejandro Block, who's the Senior Technologist, Strategy and Integration, also for Aerospace Technology Institute. And I have had a sneak preview of what they're going to take us through this morning, and it's jolly interesting. So I'm going to, without further ado, hand over to Katy, who's going to give us her presentation first of all. So Katy, I'll just hand over to you.
Thank you so much. So I'm Katy Milne and I'm the Head of Industrial Strategy for FlyZero, and I'll be talking for about 20 minutes on what FlyZero is, and then showing you a really funky video before handing over to Alejandro. So aviation's carbon challenge. Aviation emits 885 million tonnes of CO2 each year. There's 38.3 million commercial flights, and there's 4.5 billion passengers every year. So, you know, it's an emitter of emissions. It's probably responsible for somewhere between 2 and 4% of global emissions, but it also provides an important role in terms of our connectivity around the globe. Each day, Heathrow Airport uses 22 million litres of kerosene, and we think that aviation itself probably has an impact in terms of direct CO2 emissions of about 2% of global warming, but things like contrails, which are the white clouds that come out of the back of the aircraft engine, could have an additional warming effect. So Professor David Lee estimated that could be as high as 1.5%. Our target at the Aerospace Technology Institute is to help realise aircraft that have zero carbon emissions. And we also want to minimise other non-carbon emissions, so things like the effects of contrails, NOx, noise. I live on a flight path, so that's very important to me. So this is our mission, to realise zero carbon emission commercial flight by the end of the decade. You might have seen around you in the news lots of small electric aircraft coming to the market now, but we're interested in how you can push that technology further to cover larger aircraft. So Team FlyZero has been formed by the UK government and the Aerospace Technology Institute this year, and it draws upon experts from across all of these organisations. I'm actually seconded in from the High Value Manufacturing Catapult Centre from MTC, the Manufacturing Technology Centre, which is part of that consortia. And we've been working together entirely remotely for a year in order to lay down the pathways to zero carbon emissions. And we've been working across the whole ecosystem. You've seen EasyJet and NATS, the National Air Traffic Group there. But we're working with companies across industry. We're working in kind of producer space within different research institutes. And we're also working with airlines and airports as well. So what was our approach? So it's a 15-month project. It's to understand the feasibility of achieving zero carbon flight and then to lay down the forward roadmaps. We spent the first 3 months or so assessing different technology options. We refer to them as technology bricks. And there's a few that are really critical, we believe, to realising zero carbon flight. So hydrogen gas turbines, cryogenics, thermal management, and new wings, fuel cells and electrical systems. We then formed these bricks into different, what we call scout aircraft. And I'll speak a little bit more in a second about those. And we're at the stage now of creating 3 concept aircraft. Those concept aircraft will be launched later this month ahead of COP26. And finally, we're working on putting the learning that we've created through doing this into technology roadmaps and economic and sustainability assessments, which then provide the direction for the UK. And just to give some context, perhaps, which I maybe should have started with, the Aerospace Technology Institute is the UK funding body for aerospace-specific research and development. And so they distribute in the order of like £150 million of research grant funding every year. And so these roadmaps will be used to potentially direct future R&D activity. So I spoke about the critical technology bricks. This picture just shows that there are more. So we're not just looking at fuel cells. We've considered all sorts of things, including ammonia as an option. We've looked at batteries, and we're also looking at underpinning technologies such as materials, life cycle management, digital tech for compressed design and validation, testing, simulation, and we're also looking at operations technologies. So how do you do rapid and safe turnaround? And Alejandro will focus very much in this bottom right-hand box in terms of what the operational challenges are. So the Scout aircraft that I mentioned, and we created over 20 of these, and they were developed really as a way to evaluate the potential features of the aircraft concepts that represent the biggest opportunities and challenges for the integration of zero carbon emissions technologies. So the Scouts have been evaluated by the entire Fly Zero team, and we looked at them with a number of different criteria. So we looked at technical, but we also considered industrial considerations, you know, how could the supply chain achieve it? Could it be manufactured? And operations. And we even gave some thought to the inspirational element, because if industry, but also the wider world is not inspired to make this happen, then it probably won't. So this image shows some of our Scout aircraft, and I will show a video of all of them at the end. And you can see some of them are fairly familiar architectures, but some of them are much more radical. So especially if you look to the top of the screen, you can see one that looks a bit more like a catamaran aircraft. And then we've got some very novel wing structures in there as well. So we were trying to be broad in the Scout aircraft. And in the concept aircraft, which is our next phase, where we'll get 3 aircraft covering regional, narrow body and mid-sized aircraft, we'll try and combine the features which we found were most critical to realising zero carbon emissions and represent them to industry, to the aviation sector and the wider public. This shows a picture of all the different Scout aircraft. And there's some, I'm sorry, it's not very legible, but some content around like what sizes they are, what the main fuel source is, and a lot of stuff on this on the Aerospace Technology Institute website if you want to have a look. And you can see there how different they are. Perhaps if you look at the one in the middle that looks a little bit like a beluga, that space there in the fuselage is in order to keep the hydrogen. So hydrogen, kerosene, the existing jet fuel, is kept in the wings, but liquid hydrogen will have volumes of 2 or more times bigger depending upon the type of flight paths that you're wanting to carry out. And so the location of the hydrogen will have to move. So some might be in the wings, some might be in the fuselage, or you might have to change the shape of the fuselage so that you can have these kind of like storage tanks. So in terms of project outputs for this year, so of our year 1, the feasibility phase of Fly Zero, we'll have about 40 published outputs, a range of technology roadmaps, but also the sustainability and economic case. These are 3 concept aircraft. And then below, I've just listed what some of those outputs will be. So roadmap, market assessment, industrial footprint, and industrialization roadmap. I'm responsible for that bit, economic case, and the sustainability assessment. So just to talk you through some of the drivers, I suppose, or challenges, in terms of market size and CO2, regional aircraft, this is a complete coincidence, but we have validated this, that our projection is that the size of the market for regional aircraft between 2030 and 2050 will be 7%. And similarly, the emissions for regional aircraft in 2019 was 7% as well. So complete coincidence, I said. And regional aircraft emit the lowest amount of CO2 per aircraft in a given year. If you move up to narrow body aircraft, the type of plane that you'd fly to like Malaga on your holidays, then they are responsible for about 51% of the future market, 51% of CO2 emissions, and they emit a larger amount per aircraft in a given year of operation. And then finally, wide body aircraft. So these are things all the way up to a 787, which you travel all the way to Sydney on. They're responsible. I'm going to get the adding wrong. Panic. So they're responsible for 43% of the market, the CO2 emissions, and my face is covering it, but they are responsible for the largest CO2 emissions per aircraft. So what this tells us is that to really address CO2 emissions, we can't just address regional flight. We must extend zero carbon aircraft all the way up through to narrow body aircraft and wide body aircraft. And we're looking at how there may be a road to fully decarbonising emissions if you can extend the technology up to a certain size scale. This is one of the critical questions that we're trying to answer in Fly Zero. In terms of the addressable market, this image shows how the fleet sizes will develop over time. Over 90% of the global fleet at the end of 2030s are aircraft that are not yet built. So that's good news. It's an opportunity for us to put in zero carbon aircraft. It's likely, though, that due to affordability, there'll only be one fleet refresh between now and 2050. So by the time we're trying to hit our net zero targets. Due to COVID recovery, perhaps 60% of these aircraft will be delivered after 2030. So that there's an opportunity to potentially get 60% of all aircraft to zero carbon if we can deliver a zero carbon aircraft or develop it to maturity in time. And Fly Zero's addressable market lies mainly in the narrow body sector because the technology has limited application to long range. And as I said before, regional markets are really less impactful. So we really need to be going as fast as we can to make sure we maximise the number of aircraft that are replaced with zero carbon emissions aircraft. And Fly Zero, therefore, is focusing in this mid-range kind of between 300 nautical miles and 3,000 nautical miles. We see that the smaller aircraft are being developed now by the market and are fully electric with batteries. The very long-range aircraft, like the 787, will have to be fueled by sustainable aviation fuels. And we believe that it would be appropriate to concentrate the use of sustainable aviation fuels there. Sustainable aviation fuels are kerosene drop-in fuels, so replacements for kerosene. And they're manufactured by different routes. So they could be manufactured from bioproduct, or they could be manufactured from hydrogen, actually. So you take the hydrogen and you process it into a kerosene replacement. But the capacity for sustainable aviation fuels is very low at the moment. And so if that was to become a solution for the entire aviation, it would have to be ramped up very radically. So this is a slide which just seeks to compare alternatives for primary fuel sources. On the right-hand side, we've got the sustainable aviation fuels, which I just spoke about, and all of the fuels on the left are zero carbon options. So batteries is the best option in terms of emissions. So you can see it's green for CO2 emissions, for NOx and for contrails, if you can recharge them using renewable energy. Liquid hydrogen fuel cells, liquid hydrogen combustion, probably give you the best intermediate option. And the reason why you need to look at them above batteries is because batteries are limited in terms of basically how big an aircraft they can power and how far it can go. Without a breakthrough in battery technology, it won't be applicable to aircraft like, say, an A320 737 size. However, liquid hydrogen combustors, possibly supported by a liquid hydrogen fuel cell, does have potential. And you'd have seen that potentially if you follow Airbus, because Airbus announced development of their zero-E range of aircraft, which go into those medium range markets using this type of technology. Gaseous hydrogen isn't really an option because it takes up too much volume. Ammonia isn't really an option because of the amount of nitrous dioxide that it produces, and also because of some issues around safety and smell. So therefore, liquid hydrogen is a lightweight, relatively affordable fuel, and is really the best route to a green strategic capability for aviation. By strategic, we mean addressing those bigger aircraft into the bigger market, bigger CO2 emissions. So, as I was saying, battery and also fuel cell on its own, they're relevant to sub-regional and regional aircraft. Meanwhile, to get to fuel zero carbon aircraft that are larger, single arm, mid-size, you need to go to a hydrogen burning gas turbine. This slide also shows some of the systems and structures that are absolutely critical to realizing this. So in order to have a liquid hydrogen powered aircraft, you're going to need cryogenic hydrogen storage and distribution. So a cryogenic tank, a cryogenically cooled tank, a cryogenic fuel system, all the way up to the combustor. You'll need thermal management because you're going from temperatures down to 20 Kelvin and all the way up to 1200 degrees C in the combustor or higher. And you're also going to need new wings and structures. In particular, if there's no liquid hydrogen in the wing, so if you decide not to put any of it in the wing, then you'll have a dry wing, and that creates like a completely new wing design compared to what we have now. In terms of sustainability, in Fly Zero, we're assessing all of the concepts and options using this sustainability model. So if I just look at the bricks briefly, it covers the entire life cycle, basically, and it covers both the aircraft itself, but also the surrounding infrastructure and energy. So in here, we've got the energy related to the aircraft materials and manufacturing and maintenance and end of life. We've got consideration for the critical materials that may need to be used and their availability. We've got consideration of the airport infrastructure and fuel supply. And then within this box, this is the in-flight impact. So within the dotted line, we've got the consideration of the energy used to create the fuel. And we've also got the emissions from burning the fuel in the aircraft. And so we're putting in, we've got emissions models. So that's in this central box in the dotted line. And all of that goes to an output, which my face is covering again, in the bottom right, which calculates what is the full life cycle emission of an aircraft. Just to give you a bit of context, about 90% of the tailpipe emissions come from the grey box. 90% of the life cycle emissions, come from the emissions directly from the aircraft, the bit shown in grey and in green. So just a plug before we finish. So we're running, we've been running events all through the year. Our next one is actually on the 6th of October with Farnborough Aerospace Consortium at 10 AM, and you can go to their website if you want to join. It's open to people around the UK. And we're actually looking at passenger experience. Future aircraft types may have to be windowless so that they're lightweight enough to carry heavy things like batteries and cryogenic systems. And so we need to think about what the passenger experience is like on those new aircraft. And so we're running this event with the Farnborough Aerospace Consortium. In the past, we've run sessions on electric motors, on hydrogen fuel cells, and on other technology bricks. Over the coming months, we're going to be running a series of roadmap validation events. Those will be by invitation only, but if you think you've got something to add on any of the technology bricks that I showed, the critical ones earlier in the presentation, then please get in touch with us, and I'll flash up our email and contact in a second, and we can consider whether you should come to those events or talk to us in parallel in a one-to-one or whatever's most appropriate. We're trying to do the broadest possible engagement and also try and get some focused conversations as well. So we'll show you now that's me finished. We'll show you now the Fly Zero video, and then I'll pass over to my colleague Alejandro, who'll talk much more about airport infrastructure challenges. And these are our contact details. So please get in touch with us at flyzero@ati.org.uk. Thank you very much.
Led by the Aerospace Technology Institute and backed by the UK government, Fly Zero is a one-of-a-kind research project aiming to realise zero carbon emission air travel by the end of the decade. A team of experts from across UK aerospace and academia is working to develop the new technologies that we will need to propel the next generation of aircraft into our skies. And by fusing these technologies together to create and evaluate a fleet of groundbreaking new concepts, ATI Fly Zero is defining a truly sustainable future for the aircraft, airports, and airspace of tomorrow. As the global aviation industry looks to a brighter, greener future, Fly Zero will help the UK stand at the forefront of sustainable flight in design, manufacture, technology, and skills for years to come. A new dawn for aviation is on the horizon.
Thank you, Katy, for that good presentation and for the inspiring video. I don't know what you all think, but I really like that video. I think it's very cool. So yeah, building a little bit on what Katy presented, I will present this joint initiative between ACI, Airport Council International, and ATI, the Aerospace Technology Institute, on how to integrate, or a few aspects rather, of integrating hydrogen aircraft into airports. So this is all a report which is published. You can download it from the ATI or the ACI website. If you Google ATI, ACI, hydrogen airports, that will probably direct you to where this is. It's free. And I will present the background of why we did this and what's inside the report, and what we learned, what are some of the challenges, etc. So any details you can find there on the report itself. So a little bit of background. I think when we speak about how to bring zero-emission aircraft into the market, one of the things that everyone agrees on is collaboration. And we always speak about collaboration. We know that we will need to have airports, airlines, manufacturers on board. And this is a really good example of one of a collaboration between airport-based organization and an aircraft-based organization. So ACI is an organization that has about 2,000 airport members, which represent just about 96% of traffic around the world. So they are a really big influence on the airport. They hold a seat at ICAO. For those of you who don't know, ICAO is the United Nations Specialized Agency on Aviation. And as we speak, that agency is working on assessing the feasibility of having a long-term goal for aviation emissions. So we have some goals at an industry level. So you might have heard the minus 50% reductions by 2050 compared to 2005. But that is at an industry level. It's an aspirational goal. But we don't have anything at a United Nations level. And ACI is currently an active member of that working group, working on that. And also the ACI airport members recently committed to net zero global emissions. So all of these initiatives that ACI is involved in really made them wonder, okay, if we had zero emission aircraft and if our airports need to achieve zero emissions, what would this mean for airports? So it was a big question mark in terms of infrastructure, operations, etc. At the same time, we have ATI, the Aerospace Technology Institute, and Katy already gave an introduction to that. So the ATI defines the UK aerospace strategy. They have a total funding of £3.4 billion that's directed into projects to strengthen the UK position in aerospace. And about 50% of that money goes into reducing the environmental impact of aircraft. So I'll show on my next slide here a little bit more about the ATI. So with respect to hydrogen, ATI has been involved with hydrogen projects for a few years now. So here are some examples: Project Fresson, H2 Gear, ZeroAvia. These are all in the smaller end of the spectrum, so hydrogen fuel cells and so on. So there's a little bit of experience there. But of course, ATI is in the UK, and the UK has committed to net zero emissions, including aviation. So they too were quite interested to understand what are the implications of this at the airport and whether these technologies are actually feasible. There is no point in funding a hydrogen aircraft if it doesn't have an airport to land to and from. And now, of course, the ATI Fly Zero program is full underway, and you've just heard from Katy. They've chosen hydrogen as the energy carrier of those aircraft. So even more important to understand what this means on the ground and on the distribution. Now, this is a little bit of a busy slide. I do apologize. I'm trying to put 3 ideas here at the same time. So, of course, now we're talking about Fly Zero and we're talking about Airbus and all of that, 2021. And this all seems very novel. Hydrogen aircraft we've never flown on a hydrogen aircraft before. It sounds, very novel, very, very innovative. However, one of the first things we did was to look back at hydrogen in aviation in time. And we ended up looking back almost at the beginning of the jet age, when one of the first jet engines by von Ohen was built and tested with hydrogen. They actually identified hydrogen back then to be a very promising fuel for aircraft. And so we move into time with experimental testings in the US, in Russia, numerical analysis, etc., going back decades in time. So everything that we are doing now is based on decades and decades of research. And now on the top of that timeline, I have a personal timeline. My grandmother, who's still around, was born in 1927. And sometimes I think, wow, when my grandma was born, biplanes at the bottom of the screen were still flying with piston engines. And then as she grew older, we had DC-3s flying on piston engines as well. And then she lived through the entry into service of the 747 and the Concorde and the B787 and the A350. So within my grandma's lifetime, she has seen pretty much the whole history of aviation. And I think it's quite shocking because we do speak about long development times, and we're all aware of the long development times. We're talking 10 years to certify an engine, for example. Aircraft stay airborne for 20 years. But within the lifetime of one single person, we went from biplanes to supersonic aircraft to composite material aircraft. So there is a little bit of hope there. So anyway, the point of this slide was just to show that when we talk about hydrogen in aviation, there is a lot of knowledge out there. And some of that touches on airport and airport infrastructure, which is the topic of our report. So we took those learnings and then we wonder, what are the gaps that still remain? What can we learn? And how can we address those gaps? I'm moving to the next. Yeah. So one might think, okay, so if hydrogen has been considered for aviation since the 1930s, why hasn't it happened? We had these waves in the 70s and then again in the 2000s, and then is this another wave and it will die down? So we have reasons to believe that it's worth paying attention to it now because of the specific context in which we are. So never before have we transported passengers in hydrogen-powered transport. Now we have buses, trains. We have airports deploying hydrogen on site, and there's a photograph on the bottom left of hydrogen forklifts operating at Kansai Airport in Japan. We have examples like that in the US. We have examples like that in Europe as well. So we see that hydrogen is becoming a more integral part of our economies, not only for oil refining or for chemical industry, which are the two biggest applications of hydrogen, but to transport passengers and to decarbonize airports. Now, on the right-hand side, we see some snips of recent hydrogen strategies, and we see them popping all around the world, not only in Europe, in the US, in Canada, in Oman, in Argentina, in Chile, right? So all around the world, there are about 60 countries that have produced a hydrogen strategy to date. What is the motivation of this? Before, in the previous waves of hydrogen, it was oil scarcity, it was trying to ensure energy independence, rising oil prices, etc. Now the motivation is not that. The motivation is climate. We've said that we are in a climate emergency, and the IPCC 6th assessment report was dubbed a code red for humanity by the United Nations. So we are really in an emergency of climate, and this is what is pushing the use of clean energies and hydrogen, and that is not going to go away. So because of these reasons, we thought that these initiatives on hydrogen, these projects, is something that requires special attention now. So what did we do about it? I already told you we read a bunch of reports, historical reports, we found gaps, and then we listened. So we had a very extensive engagement campaign. We have on the left-hand side the people that directly contributed to our report, going from airports, universities, research centers, industry. So all up, 17 organizations were involved in this report, and the final draft was reviewed and written by 34 experts. So we had people that actually wrote a paragraph or corrected it, a lot of feedback. So that was a very extensive process. But beyond that, we spoke to some of the experts that are familiar with hydrogen today. So Enable H2, for example, is a European project of hydrogen trying to revitalize the enthusiasm for hydrogen. They're doing a lot of different experiments and numerical testings, impressive things. And NASA, of course, has a lot of experience dealing with liquid hydrogen. We spoke to them, to the experts at the Kennedy Research Center. FlyZero, of course, and so on. So we really try to get the experts' views and seeing, okay, are these conclusions from these reports that were done in the 70s still valid today? Most of them are. Where have we gone through since then, right? So all of this is captured in our report. Now, what do we have inside? We have mainly 5 sections, and I will dig a little bit deeply into each one of them, so I will not dwell on. But you see, we have a section on supply chain distribution at the airport. How can we bring the hydrogen to the airports? Once we have it inside, how do we distribute it to aircraft? Shall we bring it liquid? Shall we bring it gaseous? Shall we make it on site? What does it depend on? Safety. So of course, I'll speak about that on my slide. Airport and aircraft compatibility. This is very interesting. So if we have a hydrogen aircraft, what will need to change at the airport? And of course, the first reaction is, wow, this is going to be very infrastructure intensive. But then I ask, what infrastructure? What exactly are we going to need? So one of the reports from the 70s from NASA is very interesting, and they assessed infrastructure at airports. And one of the biggest challenges of their concept aircraft, which was a 747-sized aircraft, 400 passengers, double-decker, huge thing, was the fact that the aircraft was double-decker. And that was the biggest challenge, not the fact that it had hydrogen, but the fact that it was a double-decker airplane. Of course, we've overcome that challenge today. So it's very interesting to look at that. What specific characteristics of the aircraft will be incompatible with what specific infrastructure elements at the airport. Based on the options of whether we generate hydrogen on-site, off-site, etc., we assessed how much space it would be needed, how much energy, how much would that cost. This is all based on historical reports. Okay, so we didn't do case studies at this point. We took historical data and we translated into today's numbers. And we also saw some opportunities for airports. So now, when it comes about infrastructure at the airport, we saw that it is quite feasible to do, in the sense that we don't need to develop anything from scratch. You don't need to invent an electrolyzer to make hydrogen from water and electricity. Those elements already exist. We don't need to invent a truck that can transport the hydrogen to the airport, because they already exist. They transport hydrogen, liquid hydrogen today. There's a photograph there. We can also transport hydrogen by pipelines. Today, there are about 5,000 kilometers of hydrogen pipelines around the world. The first one was built in 1937. So you can imagine this is quite an old industry. Can we repurpose natural gas pipelines to transport hydrogen? There are many projects in Europe, in the UK, in Germany, in France, where they are looking at doing that for home use, right? So they are blending 20% of hydrogen and slowly rising that up to 100%. And the same with storage. So in terms of infrastructure, we have the elements, we have the building blocks. Now we have to adapt that to our environment, and that is a challenge. I'm not going to say it's easy, but we're not starting from scratch. However, all of this infrastructure is going to take time to build. You know, we're talking 10-year lead times, etc. So we need to plan now. We need to start acting now, and we need to start assessing it now. Another conclusion is that this is perhaps very obvious. Every airport is different. Well, obviously it is. But what's interesting is to see how airports operate today. So what we saw is you have three photographs there. On the left-hand side is Mexico City Airport, an airport that's really busy, one of the most busy airports in Latin America, in the middle of a city with 20-25 million people, completely surrounded. Receives its fuel entirely by truck. So if you zoom in onto the fuel farm, and I don't think you can see my pointer, but if you go on Google Maps and you zoom into the fuel farm of that airport, you will see the trucks lining up and waiting to offload fuel from there. So this is a practice that not only in Mexico City, but some airports around the world they use, and it is feasible. It's the most inefficient way to bring a fuel to the airport, but it is feasible. We have in the middle Zurich Airport in Europe, and you can see there's well, I don't know if you can actually see it, but there is a big sort of black line that goes from the left-hand side to the bottom of the photo. That is a railway line. So this airport receives its fuel entirely by rail. So again, an opportunity here to transport liquid hydrogen by rail. We don't need to build perhaps extra infrastructure for that. Number 3 is Auckland Airport in New Zealand, and it's a very interesting airport because New Zealand has a very clean grid, meaning that the electricity there is done mainly by renewables. You can see that airport is surrounded by water, it has a lot of space. Could we make hydrogen on site there? Perhaps we could. So very different situations, and the airports are limited by their geography, location, and the wider economic context and the energy grid as well. So what are we doing now about that? So we've identified some of these variables. We identified 3 routes for hydrogen into airports. Either make it on site, import gaseous hydrogen into the airport, or making the hydrogen offsite, liquefying it, and then bringing liquid hydrogen from outside, even from a different country. And this is happening today already. Liquid hydrogen shipments are happening around the world. So what is the infrastructure? So now we are working with 5 airports in the UK with FlyZero, and we are doing feasibility assessment for all of these 3 options for every airport to try to quantify how much space we would need for each one of them, where could we fit all of this infrastructure, how much would it cost, etc. So we now have mini master plans of these airports with the infrastructure elements in there. We're also putting this together in the context of the wider hydrogen economy around. So what happens if the UK has a limited hydrogen supply? What happens if the airport is in a hydrogen corridor? So there's just one region in the UK that has hydrogen, and this airport seems to be close by. And what happens if we have a hydrogen grid where a region or a country that is connected by hydrogen all around, and then the airport can tap in from that supply? So we're putting all of this into a context, and that is our second work package. Moving on to safety. This is a very interesting topic, and of course, some people still think about this disaster in 1937 when we talk about hydrogen. Of course, aircraft today are no longer made of fabric, flammable fabric, and it's completely different. And the application of hydrogen today, you can see there, you know, we transport passengers today with hydrogen in a safe manner. So we address 2 aspects. One is the passenger perception. What do we need to do to make passengers feel comfortable about this? You know, this is going to require an intensive campaign. We need to engage with passengers. Passengers need to travel on hydrogen buses, hydrogen trains, so that they get familiar with this. They're comfortable before they jump on a hydrogen aircraft. So it's very important. But the other aspect of it is the physics. So we compare on the report specific parameters of jet fuel versus hydrogen. You can see them there: boiling point, flammability limits, burning velocity, etc., to see in which situations would one fuel be safer or more dangerous than the rest. And the conclusion is that it depends. It's not a safer or more dangerous fuel. It's certainly different. It poses different hazards. Under some situations, it can be safer. Under some situations, it can be more dangerous. So what we need to do is to take the existing codes and regulations around hydrogen, which exist already, and we need to adapt them to our environment so that we make this safe. Of course, this is priority number 1. We will not have a hydrogen aircraft if it's not safe, and we believe that we can make it safe. So we also have a work package on this, and we're looking into turnaround operations. So what do we need to do to turn the aircraft around in the same time as a kerosene aircraft? What are the clearance distances between the refueling point and an active vehicle, for example? Can we refuel a hydrogen and a kerosene aircraft side by side Can we automate part of the process to make it more efficient and faster and safer? What are the existing regulations, as I mentioned, and how can we apply that and adapt them to the airport environment? So we have a work package on that. So all of these 3 work packages, they somewhat build on what we've done, and they are, of course, in support with Flight Zero. So very interesting outcomes that will come out from there. Now, if an airport has a sustained hydrogen supply, could we use that to decarbonize the airport? Well, most certainly, yes, we could. And if the airport is producing hydrogen on site, could the airport enable decarbonization outside of its boundaries? Could the airport provide hydrogen for road vehicles or for homes? Could the airport become a provider of clean energy? That is a very, very distinctive view of the airport than we have today, where is usually airports are associated to local air quality issues and to noise issues. So could we change that? Now today, airports receive many hydrocarbon products. They receive natural gas, they receive kerosene, they receive diesel for the vehicles, sometimes gasoline as well. All of these products could be replaced with one single product that could be hydrogen. So we looked into these opportunities, and we spoke to some of the airports that are already deploying hydrogen for their own use. So there is an opportunity there. Now, of course, with every opportunity, there are challenges. And I don't mean to simplify this and say, this is easy, we can do it overnight. It is feasible, but it will require a lot of effort. So first of all, a lot of energy is going to be required to produce the hydrogen. Even if we bring the hydrogen in its gaseous form to the airport and we need to liquefy it, the energy required just to liquefy the hydrogen might be just as much as the current energy consumption of the whole airport. So we're talking about doubling the energy consumption of that airport. Now, this is going to require infrastructure. We need to make that energy to start with, so we need to deploy the renewables to be able to make that energy, to be able to enable this. We still need to assess space at airports, especially for the most intensive infrastructure cases. If you're going to liquefy or electrolyze, is there space at the airport for this? Many airports are very space constrained. Hydrogen needs to be widespread, so we need to have hydrogen at the point of departure and at the point of arrival. There's an opportunity for hydrogen to be tankered, but still, if we're talking about flying further away, then we need hydrogens at both ends. So are we going to have that? So there are still a lot of challenges to overcome, but people like Katy and her team are really working towards trying to tackle some of these challenges. And my last point there is some of those challenges we might not even be aware of. We are still solving challenges on kerosene aircraft today. So I know that as we dig more into the details, more challenges will come that we will have to solve. But of course, human ingenuity has shown us that we're very good at solving challenges, especially when we are on crisis mode and we are in terms of climate change. So some of our conclusions. We see that hydrogen has the potential to reduce the environmental impact of aircraft. Of course, the longer the range of those aircraft, the higher the potential is. So we might see breakthroughs there. The wider economic context is key. Aviation cannot do this on their own. Aviation cannot deploy all of the renewables, make all of this hydrogen only to power aircraft. This would be too expensive. It has to happen within a wider hydrogen economy, which we are seeing today. So that is good news. But the consumption of hydrogen for aircraft has to be considered in all of these hydrogen strategies. We need to consider that this might be a reality and how much hydrogen we would need. So some quick assessments that we've done show that under a scenario where hydrogen gets deployed around the world in an aggressive manner, aviation, and it gets adopted in aviation too in an aggressive manner, aviation could use about 10% of the background hydrogen in 2050. So it's not a big number, but at the same time, it's a lot of millions of tons of hydrogen that have to be considered and produced in a green way. So we need to create partnerships. So it's no good for Airbus to produce this aircraft if the airlines are not willing to buy it and operate it, if the airports are not willing or not ready to host them. So airline manufacturers, airport partnerships are key. And of course, Katy said this already, to be able to produce SAFs, we need hydrogen too. So let's make that hydrogen green too. And hydrogen will need to be deployed, whether we use it on its own or whether we use it to refine a HEFA SAF or a PTL SAF, we will need hydrogen. And now, of course, up to date, we haven't reduced a single gram with hydrogen. It's very important to talk about it. It's very important to talk about ways to reduce our environmental impact, but we need to act and we need to reduce our emissions. So it's important to see some action. So thank you so much. I want to acknowledge all the people that have contributed to the report that I presented. You can see their names there. And of course, it's me presenting, but this is the work of a whole group of people coming together to deliver that. So thank you for your attention, and happy to take any questions.
Wonderful. Thank you so much, Alejandro and Katy. That was absolutely brilliant. Really, really interesting presentation. And I agree with you, Alejandro. The video is really good.
It is. Yes.
Really enjoyed it. You can see the response, actually. We've had some great questions coming in that I'm now just going to go through. I think probably by the nature of when they came in, some of the first ones might be for you, Katy, in respect of your presentation. But I'll allow you between you to just figure out who's going to answer. So our first question here was from Vinith. When will this project be planned to deliver aircrafts for commercial operations? So that's definitely one for you, Katy, with regards to Fly Zero.
So Fly Zero is led by the Aerospace Technology Institute. So the project itself is not building an OEM, an original equipment manufacturer, or an airframer that then delivers an aircraft. Its role is more to think about how can we get there and how can we coalesce and stimulate UK industry into action and make sure that they are acting fast enough so that two things are achieved. Firstly, the UK, which has an amazingly strong aerospace sector, is making the maximum possible contribution to this global effort to reduce CO2 emissions. And secondly, that in the case that hydrogen aircraft are the future, there's still some uncertainty about it, and that's the job of us as engineers is to try and find solutions and find routes through that. So in the case that it is the future, and people like Airbus are backing it very strongly, so very credible companies. EasyJet were talking about how we need to put everything behind hydrogen the other day. Alejandro flagged that up to me. Then we need to make sure that the UK is getting the most possible share of that future market. There's a situation where it moves to hydrogen. The UK supply chain has been very cynical and said, "Oh no, that's never going to happen." And then our aerospace sector will be gone in a generation from now. And we've got to act as stewards of UK industry really, and make sure that we don't get locked out of the future aerospace sector.
And at the moment, you're seeing a positive response from people. They are embracing it, and real engagement. I don't feel like I quite answered the question though. In terms of timing, so Airbus are talking about launching their first hydrogen aircraft in 2035. We believe it would be possible to bring that forward, and especially if the UK kind of puts its aerospace might into that activity, then it could be possible to bring that timeline forward. And it's important that we go as fast as we can because of the reasons I spoke about. So the fact that fleet replacements are likely to start ramping up in 2030, the fact that that's our only single chance between now and 2050 to make this happen. So we really have got to put everything we can at get it going quick on this. So 2030 and early years after that, hopefully we'll be seeing hydrogen aircraft engines. Which it isn't too far away, actually, Katy, in the long scheme of things, is it? It's coming around very quickly. Okay, thank you.
If I can just build on that, just a thought. Sorry, I know we have many questions, but it will take years to develop this aircraft and the infrastructure. So right now, we cannot really afford to say, we don't know what the future is going to look like. We need to have a direction, straight direction, and we need to go at it, because if we keep wondering what's going to happen, when it's going to happen, then 10 years later it's going to be too late. So
we need to act on it, have a plan and act on it. Thank you. Okay, our next question here is from Paul. I'm just going to read it out. It's quite a long question. What is the biggest challenge for liquid hydrogen, which requires huge infrastructure? But when I read the fuel choice, the gravimetric density of storage is up to 60%, which seems high. Any reasons for this? I think that's one for you, possibly, Katy.
Yeah, so I am an engineer, but I'm a manufacturing engineer. So the gravimetric energy density of the tanks storage. So what I understand that paper is talking about is what is the weight overall of that aircraft and the fuel system, not the whole aircraft, but the propulsive system, and how much bang for their buck can they get out of it? How much, like, ultimately thrust strength generation can they get out of it? And we've had a team of engineers. It's a critical problem, like if you can't get the gravimetric energy density high enough, you then can't get onto bigger aeroplanes. So we've had a team of engineers from all across UK industry looking at that question, and they believe that they can get it up to that. However, that's a preliminary finding. They're going around it again at the moment. They're getting review from other experts in the field. We had a design advisory group yesterday. But there's two ways to look at it. One is 60% is what can be achieved. The other is that's the tipping point for it going on to larger aircraft. And so really, as engineers, we should be thinking, okay, how can we make these systems high performance and lightweight so that we can achieve that gravimetric energy density?
Right, thank you. Alejandro, anything to add to that?
No, I think I think what Katy says is spot on, and I do believe that there's a range of studies that have looked at gravimetric efficiency. Some of them are a bit less, 40-45%. Some of them I've seen a bit more, 70%, 60%. Yes, it's ambitious, but I think it's achievable. And of course, it depends as well on the range and the size of the aircraft, right? So the bigger you go, it all has to do with the surface area to volume ratio. So if you have a very small sphere that has to be insulated, then the volume that you can contain there is very small. So when you compare that volume to the whole thing, then it's not very efficient, right? But then when you grow in size, then of course the weight of the tank and the insulating systems compared to what you can contain inside, it starts making a lot of sense, right? So it depends as well on a scale.
Okay, thank you very much. I'm learning lots today. A question here from Darko. How many airport owners or operators have been engaged in this project, and what are their comments on the required investment levels to achieve the proposed options? I think you've touched on that a little bit, Katy, in one of your answers just now in terms of Airbus and EasyJet. And
yes, I think this is definitely a question for Alejandro, because it's all about the airport infrastructure.
Yes, so on the initiative we had 7 airports. Of course, not only this is 7 airports that were directly involved with our work and directly provided feedback, but we also worked with ACI World, of course, which represents 2,000 airports. And we spoke to ACI Europe, we spoke to ACI North America, right? So it is 7 authored airports on the report, but the contribution from airports is a lot more. And we presented in the World Environment Standing Committee of ACI. We presented in the World Standing Safety Committee of ACI. So we had a lot of feedback from them. Now, the question about the cost of this infrastructure is quite a tricky one, because today airports don't build and they don't own the fuel farm. This is done by the fuel provider. So the fuel provider builds the fuel facilities, and they manage that facilities, and they are the owners of that. The airport doesn't generally, there are some exceptions, but generally doesn't invest in this infrastructure. So the question really is, who is going to pay for that? And that it depends on the business model. So if an airport says, well, I want to build this, I want to make hydrogen on site, I want to sell it, it's a business case, right? I want to sell it to the aircraft and outside the airport. Then the airport will invest in that. These are big investments, no doubt. But if we look at what has been happening before, then it's most likely that it's going to be the hydrogen providers, the ones that are going to be taking the initiative to do this.
Okay, thank you very much. Conscious of time, and we've got some other good questions coming in here, so I'm just going to try and fly through them. Martin has said, what collaborative initiatives are underway to ensure there is enough SAF that does not take away from food production and sufficient green hydrogen?
I can answer that if you like, Alejandro. I think so. So the Department for Transport are funding a series of projects under a banner called Green Skies, Clean Fuel. I think Green Skies, Green Fuel. And so we actually are both. So the Department for Transport on that initiative and Fly Zero on our side, reporting into something called the Jet Zero Council, which is a UK government council formed of across industry representatives, covering people from both the aerospace sector and also potential providers of sustainable aviation fuel. Our remit is to look at zero carbon solutions, so things like hydrogen and batteries. But the Department for Transport are leading this other program looking at sustainable aviation fuel, and they've just announced about 15 projects, as I understand it. It's been on social media. They'll be funded looking at things like sustainable aviation fuel, and they're also looking at stuff through a project with Connected Places Catapult on infrastructure as well, and those infrastructure questions I think are against all future fuel use fuel types. So hydrogen as well as sustainable aviation fuel.
Okay, thank you. One, I think for you, Alejandro, presumably until all airports are capable of supplying hydrogen fuel, aeroplanes will need to be able to operate using multiple fuel types. How much of a challenge is that to overcome?
It's extremely challenging. I don't think it's feasible. Well, everything is feasible, depends on how much money you're willing to put into it. But I think it will be very difficult to try to have a multi-fuel aircraft, for example, right? An aircraft that we cannot do it with SAF even today. SAF is not compatible with aircraft today. We have to blend it. So we cannot even do that with SAF, which is very similar to kerosene. So I think it will be very challenging to try to have an aircraft that will fly on both fuels. What we can do, most possibly, and we must do, is to have the two fuels supplied to two different aircraft at the airport. Now, this has challenges on its own, of course, but I think it's going to be something similar to what we saw with the 747 or the A380, that the airports had to build the infrastructure to adapt to them. And this is big infrastructure, right? They reinforce the runways, extend the taxiways, have boarding bridges, fire equipment, etc. And at the beginning, there were just a few routes where these airplanes will fly, and that with time started expanding. So I think that we might see something like that.
Okay, thank you. Another question here from John. What assessments have been conducted into the feasibility of producing enough clean primary energy to operate a hydrogen aerospace industry?
This is, we think, one of our biggest challenges or worry warts. So we're in the middle of so Fly Zero's job isn't really to solve the supply issue in terms of how much hydrogen should be supplied, but we are working to kind of set requirements. So to say, we think this much hydrogen will be needed by this year, in these types of locations. And yes, we believe that the current plans ramp up of hydrogen might be one of the key limiting factors on the adoption. And so we're trying to put in a really strong trigger and say more hydrogen production is needed, including in the UK, rather than having to import it. Alejandro, you might have some.
Yeah, exactly. I mean, I mentioned a little bit of that on my presentation. We have to look at this into a context. So if we look at the context from the International Renewable Energy Agency, for example, they have scenarios, right? So we have the stated policy scenario and they have the transformative energy scenario. So if we look at a scenario like the transformative energy scenario, where renewables are deployed in a massive scale to be aligned with the 1.5 degree scenario of IPCC, then aviation wouldn't need that much of a chunk of that, and I said about 10%. This depends on many things, so put big error bars on what I'm saying, but it has to be put into this context, and it definitely has to happen within a wider economic context. It would be unfeasible to think that aviation would have to do this on their own. Thank you.
I'm conscious of the time. If you guys can spare us another 5 minutes, I think we can get through these last questions. That would be wonderful. Thank you. A question here from Owen. How concerning is it to you that the UK government seems to be prioritising blue hydrogen over green hydrogen production in its latest hydrogen strategy? Any thoughts on that from either of you?
Well, as I had understood it, I think the logic behind the blue hydrogen was something around basically that being something they could ramp up easily in the near term, and therefore it allowing a quicker transition to hydrogen in the application, on the application side, so in mobility applications and fuel applications, as they begin to in parallel ramp up the level of renewable energy. So I understood that the reason it was there was actually because they had realized that there was a kind of this thing where the applications have to be matured at the same time as the supply, and that also the timeline to put in the renewable energy is quite long. So in that case, being an engineer, I was like, well, that makes good rational sense and is a good strong strategy. For aviation, we're targeting 2030. That's still 9 years away for first zero carbon aircraft, and then a ramp up after that. It should be our aim for all of the fuel to be produced by green sources, by renewable energy sources in that time frame. And so blue hydrogen would be a kind of an interim solution, in the same way that we see SAF, which would be made from blue hydrogen or green hydrogen as an interim solution. So yeah.
Thank you. Akash has asked here, are there any perspectives on how we could repurpose existing assets once new hydrogen-based crafts are in?
Should I give this a go? Yeah, I suppose that, I don't know if the question is about assets on the ground or assets as in aircraft assets. My take is we are looking into, well, not me personally, but as in a group of people is looking into repurposing, for example, natural gas pipelines. So that's capitalizing on these pipelines and transporting gaseous hydrogen instead. So this is feasible. I think, there's about 85% of homes in the UK are connected to the natural gas pipeline. So there's a huge infrastructure already in place. Some of them can be repurposed, some of them can't, but there is research into that. Repurposing an existing aircraft with hydrogen for combustion, a big aircraft, I think that's going to be very challenging. However, we do see cases where smaller aircraft in the regional scale or sub-regional are being retrofitted with hydrogen fuel cell systems. So ZeroAvia is an example of that. They flew a 4-seater airplane with a repurposed electric motor and a fuel cell, and now they are scaling up to a bigger one. So there are initiatives of people looking into that.
For large aircraft, the cost of that change, from kerosene to hydrogen would be so large, you're kind of at the place where it's like, well, you might as well go to a whole new aircraft. We have been looking at it, what's the pros and cons of retrofit versus a major mod on an aircraft and a whole new aircraft. And we think that the major mod scenario and the whole new aircraft scenario are the most likely.
Okay, thank you. And on that aspect of retrofit, Chris has asked, were any of your Scouts a retrofit rather than a new aircraft?
No, they were all new aircraft designs, but as I said, we have done a study on the option of retrofit.
Okay, thank you. And Akash has asked, would FlyZero's 3 concept aircraft proposals include a certification strategy?
So yeah, we're doing a big piece of work actually with the CAA on certification. And so each of the concept aircraft will have a report associated with it. And then within the ATI, there'll be behind that, safety and certification strategies. I mean, they'll be preliminary, obviously, because these concept aircraft exist really to embody the technology bricks rather than being a specific route. However, what we do want to lay out is what work needs to be done, enabling work needs to be done on certification in partnership with the CAA and working with others like IATA and the FAA in order to enable more rapid entry into service of these radical new technologies.
Okay, thank you. Thank you, Katie. And final question, and I will have this as our final question, so apologies if you have any other questions, but we are going to have this one and finish. Paul has asked, and apologies if I pronounce anything wrongly on this, allowing a ramp up with blue hydrogen requires huge investment in CCUS, and this is a fixed cost and investors will not want redundant assets, so will kill green hydrogen. Any thoughts? Also, the economics are worse for SAF with CCUS, so green hydrogen is key.
I'm not saying that green hydrogen isn't key, but I'm not close enough to the government analysis really to answer that. All I was saying was that I felt like the logic that they put forward seemed to have a good rationale. So, you know, if Paul knows more about it, then he should go ahead and talk to the government, I think.
Thank you. Okay, well, I think that's everything. We've overrun slightly, but that was such a fascinating discussion, and I've learned lots as well. So thank you, and I can tell by the number of people that have really been on this and sort of stayed very consistent throughout as well. They've obviously really enjoyed the discussion. So thank you. A copy of the whole presentation, if there was anything you wanted from any of the slides, will be available on demand on our website within the next half an hour. And then, as I said earlier on in the presentation, all of this week's presentations are available on demand as well, along with a series of webinars that we did in our first week on Engineering Futures, which was all around advanced manufacturing. So do take a look at those as well and see if there's anything there that would be interesting to watch. We have one final session this morning, which is our closing discussion, which starts at 11:30 with Amit, who is the editor of Professional Engineering magazine. So if you're around, please join us for that. If not, it just leaves me to say a big thank you to Katy and Alejandro. Thank you very much. Fantastic presentations and a cracking video as well to finish the weekend.
Thank you very much.
Thank you. And I'm now going to end this webinar. Thank you, everyone.
Thank you.